Hello. Anybody out there? Not if you. Uh, Can you guys hear anything? Crud. No, my mic works. Think. Oh, okay, cool. Hello, hello. Okay, so my thought was to start at the hardest one first. Where's the hardest one? This, right? Hardest question. This question's decidedly evil because it says of the particle increasing, but it gives a position equation. We can take the derivative of this, but what we're going to get is a velocity. So the primary problem here is that speed and velocity are not the same thing. In velocity, you can have forward velocity, positive velocity, and negative velocity, and they're different. Whereas in speed, assuming these two velocities had the same magnitude, the speeds would be the same. And so speed increasing is a lot harder than velocity increasing. If this was a velocity question, you'd just factor this or do quadratic formula or something and figure out where the value is positive. Whereas if we have to do speed increasing, we need two things to happen. So basically, in a velocity graph, if I were to graph this function, it would look something like a U because it's a parabola. And when it's going away from 0 line for velocity, we're speeding up. So we're speeding up right here, even though our velocity is negative, and we're speeding up over here when our velocity is positive. And so we need to find these two sections, both this one where we're going away from the axis in the negative direction, and this one where we're going away from the axis positive direction. So realistically, at this point, our value is negative and the slope of our derivative graph is negative. So we're looking for where the velocity is negative and the acceleration is. Whereas over on the right side, our velocity is positive because it's a velocity graph. And we're also looking for where our acceleration is positive, has a positive slope. So I'm going to come back to my equation here, and it turns out I do have to factor this. This one does factor nicely. We want a minus 14, so we got to put the minus 4 here, and the minus 2 here. That would make a minus 14. So t equals 2/3. One of our zeros of our velocity, and t equals 4 is the other zero of our velocity. And then we just head to acceleration. 6t minus 14. And we figure out the only place where the acceleration changes, i.e. where the vertex of this velocity graph is at t equals 14/6. Okay, now we have all the values that we need in order to figure out where this thing differentiates or goes. So since I already know this is an up parabola, I know it starts with positive velocity on this side of t equals 2/3. I know it has negative velocity in between, and I know it has positive velocity on the other side of t equals 4 here. So I know it's positive, negative, positive. And that's from the value being positive, then negative, and then positive here in my graph of the velocity. And then I know this point is t equals 14/6 the vertex of the thing is. So I know I want from my first critical point to that vertex here. So that's from 2/3 to 14/6, which is also known as 7/3 in options. So I know it needs to be this one already. That already matches. And additionally, on the other side of 7/3 and 4, this area over here. So we actually go a ways up past, up into this space, above points, and that's from 4 to 10, where the speed of the particle is also increasing. Whoa. Okay, so I just jumped into a pretty heavy one. Did I lose anybody? Are there any other questions people want to ask? I'm happy to go any direction from here. So hello to everybody. A lot of people said hello. $11. Where did 6t minus 14 come from? 6t minus 14 is the derivative of the velocity. So I just took the derivative of 3t squared. That's 6t, and negative 14t as a derivative of negative 15. I have no idea what happened today. What did happen today? Oh, I returned a bunch of tests and people looked over things. So like the free response, that kind of stuff. And the multiple choice from last unit. All right, looks like 7, 9, and 11 are my next destination. So 7's right here, so I'm going to start with that one. What is the position of the particle when it is farthest to the left? So this is an absolute extrema question. Farthest is like an absolute minimum, because left is values function that's moving along the x-axis. If you couldn't picture this question, basically we have an axis here. That was supposed to be flat. It didn't work out. But yeah, this is the x-axis right here. And this is 0. And when we have a positive value, we're going this way. And when we have a negative value, we're going this way. Oh, goodness. So that's kind of the idea with the question. So when we're farthest to the left, we're at the absolute minimum value for this x of t function. So for this, we're going to need to use the 2 zeros of the derivative, the 2 zeros of the velocity equation, which are the critical points of the position equation, and they are 2/3 and 4. But we also need to test the endpoints 0 and 10. Okay, but there's like a cheaty shortcut to this, because if you look at the velocity graph I drew up here, we go up and then we go down for a while. Sorry, we right at the beginning and then left after that. So this area down here is left, and this area, this place up here is right. Any positive velocity is right, any negative velocity is left. So there's only really 2 points I need to check. I need to check the starting point, 0, and that one's really easy, 0, 5. And I need to check this critical point right here, because that's where I've just been decreasing a lot. So I got to test 4 also. So 4, if I plug 4 into this thing, what do I get? My little pad here. 64 minus 7 times 16 plus 4 plus 5. All right. What is this? 129 minus this thing. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 129 minus 7 times 16 plus 4 plus 5. 7 times 16 is 112. That's 17. Is that math right? Oh, I goofed hard. I thought I was plugging in 8. I'm supposed to plug in 4. That's dumb. All right, so it's 32. So this number is supposed to be 196 plus 5, 101. So 101 minus 112 is negative 11. And so that is definitely when we're farthest to the left. Now, you could check the other critical points, but plugging in 2/3 just really doesn't sound that fun. So knowing this trick can get you can help you avoid a lot of work. If it was farthest to the right, by the way, it'd definitely be 10. 10 to the third is pretty large. So that would dominate. Hopefully that made sense to people. I'm using a lot of parent graphy stuff today. I'm not sure why. I dig that. Let's go to 11 next, and then I'll go to 9. And feel free to go back to questions if you don't know what happened or steps or anything. All right, so in this question, we already have the derivative. It's already factored. So we know our critical points are 2, 3, and 4. And if you're really savvy, you've paid attention to the fact that even roots aren't actually maxes and mins ever. So we could just kind of rule out 3. So we just got to test 4 and 2. I mean, really, I should put 3 in there so I don't pick it. But 3.5 and 5 and 1, and I mean, I can use 5. Trying to think if I jump into another paragraph thing. Okay, so what just to jump over to the paragraph thing before I solve all this stuff. X times x cubed, or even if you put in the x squared, is going to be an even up function, something like this. And so we kind of have a picture of what this thing looks like, roughly, which can inform us going into these other parts. Like, it clearly has more going on, but we're going to uncover that shortly. Doesn't look, by the way, either of these. So at 1, if we plug 1 in, we get negative times negative. That would be positive, which is increasing. If we plug in 3.5, we would get positive times negative. That's negative and decrease. And if we plug in 5, we would get positive, positive. That would go back, increasing. So we have a minimum at 4. That's not one of our options. We have a maximum at 2. That is one of our options. And so it's the maximum at 2. How can you take 3 out? Even roots don't really impact sign. So if I look at x minus 3 squared, this homie, this thing, no matter what I plug in for x, 5, 2, 1, 0, it's always positive. And so that means it never impacts the sign of our questions. So that means across that point, it does not change sign in its value. It's 0 at that point, the derivative, but it doesn't change sign. And so that picked me up there. Hopefully that made sense. Oh, hello, Caden. I've brought you up some this year, I think. And a Matthew, I'm getting brigaded by former students. Okay, so I'm gonna pop up to question 9 now. Okay, so which of the following is an equation for the line tangent? Okay, so anytime you see line tangent, there's 2 things you need to know to make a tangent line. You need a point and you need a slope. And so, unsurprisingly, point slope form, y minus y1 equals slope times x minus x1, is usually pretty helpful to plug stuff into at this point. You can use slope intercept form. It's just, I tend to use point slope because you're always going to find a point and always going to find slope for this. So a nice part about this is they happen to tell you that x equals 1. So that's already a freebie. I can plug in 1 into this function and figure out what y is, or what f of x is here. So f of 1 would be, if I plug 1 in, 1 to the 5th times 2. So it's 2. So sweet. I know 1 comma 2 is my point. So you check on the first thing, on the point. Now we're going to go to the slope, and this is kind of a pain in the butt because we got to do a product rule with product here. So derivative of the first is 5 times 2x minus 1 to the 4th times 2 times the second thing, x plus 1, plus the first thing, 2x minus 1 to the 5th, times the derivative of the second thing, which is 1. And now we just plug in 1 again as our x value, and we get 5 times 1 times plus 1 to the 5th. And this is 20 plus 1, which is 21. So I know my slope is 21, so immediately yoink. And I know that my point is 1, comma 2. So I'm going to get y minus 2 equals 21x minus 1. And if you distribute the 21 here and then add 2 to both sides, pretty clearly get this homie right. By the way, the questions on this review are actually quite similar to the questions on tests. The only caveat is on the tests there are 2 optimization questions. But they're the easiest or quickest kind of optimization question. I know because I wrote them today. So I would not say, oh, optimization, I'm just going to take an L. Like, go and look at the easiest optimization questions and make sure you know how to do those ones. You're probably going to be okay for optimization. What does tangent mean? Arkin? This is not a Cruisich review session. But tangent means it touches a curve exactly once. And at tangent lines, the slope and the value of the curve match perfectly. That's a tangent line. Also, tangent means something different in a circle, but kind of the same thing. If you've ever nerded out on circles in like pre-calculus or something, the sine is the y value, the cosine is the x value, and the tangent is this value, which is tangent to the curve. So it actually. And no, I'm not explaining what maximum. Uh-oh, my bit rate. OBS says my bit rate's okay. Arkin is contributing. Any other questions people want me to do? I exhausted the list in chat. I can go to anything else. It doesn't need to be on the review. Okay, for 10, why is it x is greater than 2 instead of x is less than? Let's find out. 3x squared minus 12x. Oh, I know why, because my power is flickering because of the windstorm. Yeah, that makes sense. 6x minus 12, so 2 is our inflection point, potential inflection point. And if you test 1 and 3 in this function, 1 would give us a negative, so that's concave down, and 3 would give us a positive, so that's concave up. So where is it concave up? After 2, because 3 plugged into this second derivative yields a positive value. How about 15 and 16 for fun? Are they fun? Oh, yeah, these are fun. All right, so for 15, at what value of x does f attain its maximum value on the closed interval given the derivative here? Remember how to do this? Oh, yeah. So we set sine of x cubed equal to 0 because we're setting the derivative equal to 0 to find its maximum. Because one of the critical points will be the maximum. So I want to graph this. There's an integral reason for this, but anyways, so the first critical. Okay, I'm gonna give the integral reason. So if I graph the derivative, it looks something like this, and the derivative is the slope. So what this tells me, since it's a sine function, I know it's like up hump, down hump. That's how sines look. This tells me that I have positive velocity in my original function, or positive slope in my original function for the whole first bit. So I know that first critical point after 0 is the critical point I'm looking for. So I don't actually want to set sine x cubed equal to 0. Okay, so I do want to set sine x cubed equal to 0, but I want to set the inside equal to the first time that sine equals 0 after 0. And in a normal sine function, that point is pi. And so I just set x cubed equal to pi, cubed root both sides, and I get x equals the cubed root of pi, which is this one right here, if you round to 3 decimal points. Kennedy, my Wi-Fi went out. Oh yeah, rip. Nothing like a live stream during a windstorm. All right, 16. If I take the derivative of this thing, I get 2x equals 5 plus, darn it, I have to do a little bit of product rule. 7y plus 7x y dx minus 12y y dx. Yep, that's the derivative. So we know we have to move the crap over here on the right side over to the other side, and we already know the answer. If you got this far, check it out. We have that right here. So we're kind of done that question. Whatever I just did, do it again. Confused I am. Oh, crap. I messed up. Which one did I do? Okay, so I'll just review both of these. In the first question, what I did was I set the derivative equal to 0. And then what I did was I looked at this graph and I said, I know that the maximum value would happen after I have a whole bunch of positive slope. I graphed the derivative, so I graphed the slope equation. This is all positive slope, this up hump area. And so I know the maximum happens at this kind of critical point where my derivative switches from positive to negative, and that happens in a normal sine graph. Sine usually goes, oh, positive, 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 and then we switch right here at pi to negative values. So that's why I set the inside equal to pi. So I know that critical point is the one where I'm going to attain a maximum on the interval 0 to 2. Then I just cubed root both sides and got the answer. The second one, I just took the derivative. There was one single product rule. And if you just subtract 5 minus 7y and realize you're going to divide by this crap, you can instantly match the one that happens to have the top of exactly what you wanted. Hopefully that unmushed whatever people were confused with. Looks like it was 15, that the main using one. This is a calculus stream. It is. I do 12. I do an optimization. And Q1. 15 is much worse than 16, true. So if f is a continuous function on the closed interval a to b, which of the following must be true? So which one of these has to be true? So we have a continuous function. We have a closed interval a to b. So what's true on a continuous function? Well, the intermediate value theorem's true. So is this one of those types of questions? Do I just have to go through all the y values in between? There is a number c on the interval such that from a to b, there's a y value that happens to be in between the two endpoints. That seems plausible, but why does b have to be bigger than a? I don't buy that one. Is there a point where the value equals 0? Why would there have to be? I drew it here equaling 0, but it could just as easily be between these 2 points. So I'm going to say no to that one. Is there a number c such that f of c is less than or is greater than or equal to f of x for all x on a to b? So what that means is there a maximum at some point on the interval? That seems plausible. That one seems okay. Like, yeah, there's a maximum point. Like, it could be the endpoint. It didn't say it was in between. It just said on A to B, so it could include the endpoints. And in my little booty drawings here, the endpoints were the highest points, but in the curvy drawing, would have been like here. So that seems plausible. That one checks out. Our next one, is there anywhere the derivative must equal 0? My lines disprove that. My curve had it, but my line did not have it. So no. And is there a number c such that the derivative of that value equals f of b? Okay, so this one is the mean value theorem from this unit. And the reason why this one's not legit is this word is wrong. Continuous is not the right word for the mean value theorem. You need to see the word differentiable. If it was differentiable, it could be the mean value theorem one. The E would have been a reasonable option, but it's not, so that one's trash, and we get rid of this one. So we have now proven it's definitely not A, B, and E. A, B, and E has to be C. Did I do 12? The answer is I just did. Cool. So let's look at 1. I wrote hello world. That's not an answer to that question. So for these for these questions, what we do is we do y2 minus y1 over x2 minus x1. And if we plug in 4 and 0 into this function, we get the square root of 16 minus the square root of 4 over 4 minus 0, which is 2 over 4, which is a half. And then since you have to find the value of c that satisfies the mean value theorem, what you got to do is you got to set 1/2 equal to the derivative of this equation, would be 1/2 3x plus 4, the negative 1/2 times 3 for the chain rule. What do we do? Multiply both sides by 2. We get 1 equals 3 over the square root of 3x plus 4. We can multiply this square root over to the other side. I just rewrote the 3x plus 4 to the minus 1/2 here. Get square root of 3x plus 4 equals 3. This is where you can square both sides. We get 9 equals 3x plus 4, and now this question is light work. It's an algebra 1 question. Subtract 4, divide by 3. X is 5/3. And that's the value guaranteed on our interval. Mean value theorem only applies to derivatives then. If I pop back to that question, yes, if you check it out here, the derivative equals the crappy derivative, the average rate of change. So yes, the mean value theorem is all about derivatives. It's where does the average rate of change equal derivative. And so you have to be differentiable. So 1/2 is the slope on number 1. Yes, 1/2 is the slope on number 1. Then you have to like set it equal to the derivative to figure out where that happens. So it would have been really evil if I had made this multiple choice 1/2 here. That would have been really mean. I think a lot of people picked that. That. Bro, how would I do that? Oh. The questions on this are like real similar to what's on the tests. Like question 2, reasonable. Question 3, reasonable. Likely. Question 4, very likely to have an inflection point. Straight up question. Relative minimum. Oh yeah, like this review is very good based on what I saw of the tests today. Don't like bait questions? I don't even know who you are. So, oh, I did 6 at the beginning of the stream. So, big idea, speed is where the velocity and the acceleration match. Again, a match sign, positive, positive, or negative. And your speed is decreasing when they don't match. That was the big idea for that question. Question 2. F of x is a continuous function, blah, blah, blah. This is its derivative. On which intervals is f of x increasing? So all I have to do is figure out where this thing is positive. So I'm going to immediately rule out the x squared. It's irrelevant. And the reason I do that is x squared is always positive, so it's not going to impact my sign at all. The only 2 things that can impact my sign are 1 on the bottom or -1 on top. And I know I can't plug in 0, so I'm going to pick a number like 0.1. And then I'm going to pick -5, and then I'm going to pick 5. If I plug in 5, they're both positive, so that's increasing. So after 1, that's a thumbs up. If I plug in 0.1, the bottom is negative, but the top is positive. Positive over negative is negative. And if I plug in -5, they're both negative, increasing. So we're increasing on the edges, so it's just this one right here. I'm not going to remember any of this as mates. Rough. These are supposed to be hard versions of the test questions. Test is that true on this review? I think this review is exactly the difficulty of like exactly. Outside of this question, this is a little extra. Everything else is like right on point, including this one and stuff. Why can't you plug in 0 there? So the reason I can't plug in 0, which question was that? Was freaking. Yeah. Okay, so the reason I can't plug in 0 is I crossed out. Eraser. I crossed out this x squared. So if I plugged 0 into this, I would get 0. So I didn't plug that in because it would 0 out my equation, and I'm not actually decreasing there. I mean, technically, I could call that a critical point. I could put the 0.1 over here and test negative 0.1. That would also be decreasing. And this would be like the most official way to do it, the way we did it in class and stuff. But you can also use the trick where anything squared will always be positive, and you can use that to eat the amount of work you do on questions. Optimization, which I guess would be 17. Is 17 optimization? No, that's related rates. So I should do an optimization question. That came up. So let me see if I can find something nice on the internets. Optimization calculus sheet. First Google link. That is my mouse. I totally lost my mouse. Disappeared from my screen. Concerning. Also freaking out and blinking. Oh, I see what's up. Okay, no, that was user error on my part. All right, let's check this out. This looks good. Calculus worksheet on optimization. Look, it even has answers. Sweet. Power of internet searching. All right, so what looks good here? This one has a picture already. That's pretty cool. I'm gonna do this one. 6 seems fun. Okay, does this allow me to draw on the screen? Interesting. How do I force any of my buttons allow me to draw on them? No. I gotta be sneaky. Wink. Bird. All right, so we have 200 meters of fencing, and we're making either one square enclosure or 2 separate square enclosures of any size you wished. It's not really any size you wish, I guess, because you have to use 200 meters, so that, like, if you use one, it's 50 by 50. That's the only way that you make 200, so this is, like, really misleading. Any size you wish. So we know what the area of this one is. This one's 2,500. And if we put it into the 2 little ones, well, each of these would have to have a perimeter of 100. The same. So that would be like 10 by 10. So we'd know we'd get, wait, not 10 by 10, 25 by 25. Yikes. Daisy. That's how we get a perimeter of 100. So each of these would have an area of 625. Yeah, that's clearly a lot less than 2,500. And that is the only way to make squares of the same size. Now, we can't make 2 separate squares of any size we wish. So this, I should look at a little more detail. While I know this makes an area of 1250, I should actually, like, maybe calculus this out and figure out if that's the minimum. So this is, if I call the sides of this x and x and the sides of this y and y, I could say that x squared plus y squared is what I'm trying to minimize the area of. Oh yeah, I was supposed to get my question. Rather. Oh goodness. Donde está my stream? There it is. Please do 17. Okay, I'll pop back and do 17 after this. So anyways, this is that equation. If I were to make up my whole area of the, if I were to make my whole perimeter up of my 2 little squares, I know that the perimeter would look like 4x plus 4y, and that would equal 200. So this is the equation I can solve for one of the variables in. It doesn't really matter which one I solve for. X and y are, like, treated exactly the same. So y would be, if I subtract 4x over and then divide by 4, 50 minus x. So I could plug that in over here and get x squared plus 50 minus x squared equals minimum. I could just mob a derivative right away. 2x plus 2 times 50 minus x times a -1 for the chain rule equals 0. I could distribute -2 to both of these things and get 2x minus 100 plus 2x equals 0. And if you're super savvy at this point, you realize 4x equals 100, x equals 25. That case that I gave at the beginning, where I used 25 for all the sides in both of these, made them exactly the same size, happens to be our critical point and happens to be our minimum. We can prove it by plugging in values on either side, like 1, I don't know, 50 or something. And we get positive, negative in this 4x minus 100 equation. So this is like a classical level of the difficulty on the test sort of question. Although I wouldn't ask you 2 because it's a multiple choice, so I'd just ask you for 1, either least or most. Is there an answer key for the packet? Yep, there is. Did that sate people looking for an optimization question? If so, I'm going to pop back. Well, anyways, I'm going to pop back to the other one and do the last question, since I was asked about this one. So sides of a square are increasing at 5 meters per second. The radius of a circle is increasing at 2 meters per second. We know S and R. Which shape's perimeter is increasing faster? So all you have to do is find the perimeter equation. So the perimeter equation of a square is 4S. The perimeter equation of a circle is 2 pi r. If we take the derivative of these things, we get 4 ds dt and 2 pi dr dt. And those things we know. Dr dt is 2, s dt 5. And so now all we have to do is say which one's bigger, 20 or 4 pi, and 20 is bigger. So which one's here? Square. For the area one, you would just use pi r squared for the circle and s squared for the square. The derivatives are 2 pi r dr dt and 2s ds dt. You plug in the stuff you know, so r is 4, like 8 pi times dr dt, which is 2, and 2 times s is 5, s dt is also 5. So now it's the game. Which is bigger, 16 pi or 50? And I think 16 pi is... I think that one wins. That's how that works. Did I get that right? Is 16 pi bigger? 16 pi. 16 pi is 53.4. Oh yeah, easy. Oh, no, that's 17 pi. Oh gosh darn it. 16 pi is 50.26. Okay, whew, still good. Sometimes lucky. Okay. What would that question look like in multiple choice format? Just ask for one of them, and I don't know. Probably what this, if 17 was a multiple choice, it'd probably say perimeter, square, area, circle, and then all 4 iterations of this as the 4 multiple choice options. So perimeter circle is bigger, and then area square is bigger. And so you just need to match the correct circle, circle, and square, square. Those would be the 3 options, or 4 options rather. Low-key, I get to that step and struggle to figure out which is bigger. Yeah, it's a calculator question. Because 16 pi is so freaking close to 50. Like if this was on a no calculator, it'd be like 20 pi. So you know, like 20 times 3 is 60. That one's definitely bigger. So this question on a no calculator would be a 5 right here to make that a lot more obvious. For both of them. Barley bigger? It's barley bigger. Did I say barely or barley? I'm not sure. People sated? People want to see another optimization? I could do like a fence one. Those are pretty light. They're really boring. They're so light. numbers multiplied together. Box. What else is in this one? Ones with money. Offshore oil well. Oh, those are tough. Look at your notes. It's going to be exactly okay. The two optimization questions could be directly out of the notes with minor tweaks. They're both directly out of there. I guarantee you. And they're not the arch one. So, hopefully that gives you some insight into what's going to be the optimization question on the test. Fence. Offshore. No, I'm not doing offshore drilling. I'm definitely not doing that one on the test. The easy ones are going to be on the test. I'm not doing an offshore drilling one. Not that they're super hard, but I already wrote the test, and I know it's one of the easier ones. So I can do a fence one. They are boring, but boring can be good. So let me pop over and grab one of those. Where was that? Tab, did I have that open? Oh, whatever. Problems calculus worksheet. Okay. So I'm gonna yoink this one. This one is very basic. Boink. Wait here. Okay. Let's this here. Okay. Suppose you had 102 meters of fencing to make 2 side-by-side enclosures. This is almost exactly the question in the notes. Let's make it more exciting. What if I made 4 side-by-side enclosures? That's more fun than 2. Cool. Now I have 4 ones. That's more fun. All right. So each enclosure is like x by y in dimensions. They are going to be equal. You don't make them equal, it makes this problem like way harder. So each of these are going to be x, and each of these are going to be y. So how many x's do I have? 4 on top, 4 on the bottom. So that's 8 total x's. And I have 5 total y's. And that equals 102. Uh-oh. That number doesn't look very nice. All right, and then the area of this is going to be 4x long and y tall, and that's what I'm trying to maximize for this. So I'm just going to solve for either x or y in this equation. Which one should I solve for? I gotta solve for y. Y sounds good. 102 minus 8x over 5. Seems good. We're going to chuck that in back over here and get 4x times 102 minus 8x over 5 equals area. Okay, I'm going to distribute the 4x to both of these and get 408x minus 32x squared over 5 equals area. And now I take the derivative, and that's just 408 minus 64x over 5. Now you thought this over 5 thing might be really horrible for us, but since we set the derivative equal to 0, it's irrelevant. It does nothing. So all I have to do is figure out what I multiply 64 by to get to 408. So 64x equals 408. So x equals 408 over 64. What does this simplify to? Let's see, 4 goes into top and bottom, 102 over 16. 4 does not go in, so 2 goes in, 51 over 8. Seems good, 51 over 8 meters. That's x. And y would be 102 minus 8 times 51 over 8 over 5. Otherwise known as, doinky doinky, 51 over 5 meters. Chillin'. Notice how this question, despite the fact that I added sides and it had a janky number, really wasn't hard. We got both the answers pretty quick. I've been right maybe 6 times this year. That's not true. Jack's been right a lot more than 6 times this year, Calc. Are those Cheerios? Yes, they are. I got 1 box of Cheerios and 2 boxes of Cheerios. One's empty though. Oh, I have 3 boxes of Cheerios. There's another one here. One had the most. No, Nate, we're not doing 1,400 feet of wiring to make a dodecahedron. That's an AMC question. That's a lot more work. I mean, you can do it, but yeah. 2 boxes, crazy. Oh, dude, you have no idea. So apparently, Costco had the 2 big boxes for $3.19. So my wife got a crud ton of them. I like Cheerios. So and they went up in price to $3.99, and I got another box of 2 boxes. So these were some mad cheap Cheerios. What a deal. That's some math. Would you recommend Khan Academy for optimization problems? That's a great question. Would I recommend Khan Academy? Let's check it out. What's this Khan Academy optimization? Look like their practice. Last top question. Let's type in a bad answer. Check, try again. No, I want to move on. Skip for now. A triangle. Yeah, that looks reasonable. Yes, get it wrong. Skip. Okay, the third one's a little bit hard. That's a little harder than the ones we did in here. Skip. And the fourth one, yeah, these are all fine. All the ones on here are fine. Yeah, and it looks like they have a profit one, which is good. The profit of a factory, cost of material. Yeah, no, Khan Academy is good for optimization. I just checked it out. Oh yeah, I realized I didn't do that on screen. I was looking at the Khan Academy optimization module. The one thing that I have that they don't have is the kind where you figure out like the maximum yield of an orchard or something like that. So that's what you wouldn't be practicing doing theirs. That could be on the test. I was gonna pull that up, but then I realized I haven't searched my website. Sites. I was gonna pull up the type just in case you don't know what I'm talking about. We had quite a few, like the cattle yield, those sorts of questions are good ones. Practice in addition to the ones on Khan Academy. So ones like, oh, my notes on here is outdated. It doesn't have the good question. Oh, rip. Well, don't look at my website either. Your notes in class are better. Gotta update that. Nicole being right about something. Jeff and I agreed. Honey Nut Cheerios are better. No, that's wrong. Put some banana and blueberries in there. Blueberries are pretty awesome, so I'm actually with that. Regular Cheerios with chili power. Whoever King Bomber has brain defect. Powder. I put the purple Kool-Aid in my Cheerios. Yum. No. Gross. Anyways. I think we're through with the questions. Looks like absolute tomfoolery is happening in the chat. So I know you did it earlier. Can you do 12? I'll revisit 12. I don't know if I can bring myself to do it again. So 12. The one it was there needs to be a high point at some point in the interval. The reason why it couldn't be the mean value theorem is because the function was not differentiable. It was only continuous. We know nothing about whether or not it has a relative maximum or minimum. It could just be a straight line. That's why I drew these pictures. Straight lines have a highest points, like at the beginning on my straight line, but they don't have a relative maximum, like relative high point like the curve does. We also don't know it goes through 0. That's why I drew the line up here. We know nothing about what the y values of this curve are, but we sure as heck know that one of the points on the interval is the highest, which is all C means, and why C is right. I heard my name and then I heard mumbling. Oh, did I say your name? I don't know. King Bomber. Any chance you could do a review on concave up and concave down? Which one did I do on concave up, concave down? It was, whatever. You've been here the whole time, I think. So I go to this doc. Literally, all you need to know for concave up and concave down is take two derivatives, find the second derivative, and then, given what it is, x equals 3/2 is what makes this 0, and then test on either side. 1 and 2 could be what I test, and 1 plugged in would give me a negative, that's concave down, before my inflection point here, and 2 plugged in gives me 1, which is positive, which is concave up after that point. So it's really just like increasing and decreasing in the first derivative. Concave up and concave down is that exact same set of steps in the second derivative. Miramont's power is out right now. Oh, sad. You like to watch me suffer. Am I suffering? Doing all right. Yeah, and Amy is weird. Yeah, King Bomber. Let's see. Is that Caleb who? Because yeah, we're gonna ban that person. I had to hide one of their things, so they have now been banned for 10 minutes. Anyways, I hope you guys have a wonderful day. We don't have the test till Thursday, but I'm not here for 4th period tomorrow. So I'm going to have the sub hopefully give you back the free response you took. But I'm sorry. I'll probably be back for the second half of period 6. But yeah, I have a doctor's appointment tomorrow, so I'm missing period 4. How do you get banned from in 2 classes I have banned people, or in 2 live streams I've now banned 2 people. Caleb was the first one, and whoever was that. So negative no, it's literally the negative values are concave down, so before I get to that inflection point is concave down, and after I get to that inflection point is concave up. So up is after. And if it switches concavity at points, which it does at 3/2 here, that's an inflection point. So maxes and mins in the second derivative thing, those things give us inflection points, that whole check for maxes and mins. There's a snow day, will you delay the tests? Yes, I will. If there's a snow day on Thursday, which is like reasonably likely, if there's a 1-hour delay, we're still gonna have the test. If there's a 2-hour delay, we're not gonna have the test. So that's the scenario, because we just don't have enough time if there's a 2-hour delay. Class is a lot shorter. We won't have one, guys. The jury's still out on that. We got more snow today at school than we thought. Miramont definitely got more, so we'll see. Anyways, adios, amigos. Hasta la vista. No manifest. What's wrong with you? All right.